Hi, hello friends. Welcome to the today's session. Welcome to Unacademy and welcome to my classes. In this session, we are going to discuss about the continuous lecture of ER model. What are the different types of constraints which are there in ER model we will discuss. Before discussing, we all say our anthem that crack GATE and ESE with India's largest learning platform, none other than Unacademy. Get Plus subscription and access unlimited live and recorded lectures from India's topmost educators. Dear friends, myself is Srinivasrao IS, having more than 15 years of experience in the GATE with various subjects. Also had hands-on experience in the database side, routers, switches, firewalls, gateways, and operating system. And dear friends, throughout the journey of GATE, I taught in many premium academies with a high success rate. Many of my students got completed their post-graduation from India's topmost institutions, IITs and NIITs, Central University, Triple IITs. You also can achieve such kind of success just by giving competitive examination like a GATE and clear your goals. You 100% is going to be sure to clear because your goal is an academy goal. An academy is going to take parenting 24/7 to you. So this is the best benefit you can able to utilize, how you can able to crack the GATE examination and how you can able to clear your goals. And dear friends, many of my students are also settled in at higher positions. Some are in PSU, some are in the software, and some are also parallelly doing GATE educators. So you also can do all these things better by giving a prestigious competitive examination called GATE. So GATE examination is a completely negative marking approach. Therefore, there is a requirement of proper tips and shortcuts and a training. Without training, without tips and shortcuts, it is hard to break the GATE rank. So, to do such kind of things, an academy is providing two different programs. One is Plus, the other one Iconic. So once you become a Plus member, you're going to see that live sessions, live quizzes, mock test, and mental ability sessions, which are all going to provide you or strengthen you to clear your GATE examination as well as public sector undertaking examinations. And dear friends, the other one is Iconic subscription. You're going to have along with a plus, along with plus, you are going to have 1:1 personal coach. Therefore, friends, unique program. Use this unique program so that you are going to be benefited much more because it is a 1:1 personal coach. And the subscription plans are so long term and super long term. If you use my referral code, then you are going to get a good amount of concession on long term and super long term. This is can be first and second and third year students, BTech, and MCA students also can write GATE examination, even MSc also. And this your long term plan can be opted by fourth years, and 18 months can be opted by second and third year students. Dear friends, after applying my referral code, these are the prices you're going to see that. So my referral code is eligible any kind of a course which is there in an academy. Please refer so that you're going to get my guidance too and my alumni guidance. According to Iconic subscription, so long-term and super long-term plans are there. My referral code is also eligible to get the maximum concession. So these are the final prices. Dear friends, share my referral code, unlock my referral code and get the cash benefit. So let us start our today's session, the constraints which are there in ER model. The first constraint is structural constraint. So we mainly focus on to structural constraint because the remaining two constraints are used in hierarchy like a specialization and generalization, which are the extended features of your ER model. So almost all we see that structural constraints are going to be very much important in ER model. And dear friends, what is a structural constraint? So structural constraints mainly deal with two important properties. One is cardinality ratios, the other one participation constraints. Only two properties are there. So cardinality ratios are telling that how an entity is participating in the relationship, how many times an entity can be used in the relationship. So cardinality ratio is talking about maximum occurrences. Participation constraint is taking about minimum number of occurrences in your relationship. So both are talking that how the entities are being represented in the relationship. One is speaking about maximum, one is speaking about a lower limit, upper limit and lower limit. According to cardinality ratios, there are four upper limits are there. One is a 1:1, the other one 1:many, the other one many:1, the other one many:many. According to participation constraint lower limit, we are having a two. One is a total participation, the other one partial participation. So how are you going to represent your cardinality ratios? Using two different. This is an indication of what? One, and the straight line indicates many. So whenever constraint is not specified cardinally, then you need to understand the logic such that arrow indicates a one and a straight line indicates many. According to participation constraints, I said total participation means double line with a many, and total participation double line with a 1. The total participation is many with the total participation, 1 with the total participation. If you talk about the partial participation, a single line with a many and a single line is with a 1. So dear friends, using these terminologies which are referring to cardinality ratios and participation constraint. Now let us focus on to this area in this session, that is a cardinality ratio and participation constraint. So when you talk cardinality ratios, these are meant for binary relationship. This is a very, very important point. The cardinality ratios we are going to check only between binary relationship entities. So what is a cardinality? Express the number of entities to which another entity can be associated by a relationship. Okay friends, so the cardinality ratios and participation constraints mainly that how they are behaving with your relationship. So the cardinality ratio for a binary relationship specifies, as I already told you, maximum occurrences of a tuple in the relationship. The maximum number of times an entity can participate in the relationship. Therefore, every entity has got maximum cardinality, as well as with the help of participation constraints, every entity also has got minimum cardinality. So maximum cardinality is speaking using cardinality ratios. They are 1, many, that means 1 is to 1, many is to 1, 1 is to many is to many. And when you talk about minimum cardinality, that can be represented using the other structural constraint, that is total participation and partial participation. Therefore, every entity whichever is participated in the relationship has got maximum occurrences and compulsory minimum occurrences. Compulsory minimum occurrences partially means 0, totally means 1. So don't worry, you will see the very beautiful examples to get the difference between how an entity has got maximum cardinality, how an entity can be represented minimum cardinality. So the types of mapping cardinalities, 1 is to 1, how will you represent? So this entity is representing in the relationship 1 and other entity is also representing in the relationship 1. Arrow means 1. When you are talking 1 to many, so this entity is representing 1 and it is representing to many. You can also write in other direction, and this is many and this is 1, and the other one is one direction. You can write in either side, no problem, many to many. So these are the types of mapping cardinality. Now you may get a doubt that how are you going to discriminate the 1M, M1, MM? Listen the story carefully. When I say 1 to 1, among E1 and E2, I can also represent this in a different way. Please listen. I am writing a cardinality constraint here. 1 and 1. You can also write the limit like that. So what is the meaning of that? An entity of E1 only once in your relationship R1. In other side, an entity of E2, that means a tuple of E2, is going to occur only once in your R. So this is a 1:1 relationship. For example, last session I already discussed that an employee works only in one department and the department consists only one employee. Otherwise, a student can take only one book and a book can be given to only one student. There must not be any kind of a duplicate. That's why whenever you speak about a 1:1, the redundancy in the relationship is what? 0. You never see a concept of duplicates here because one tuple only once. So 1:1 always leads to non-redundant data. Therefore, your redundancy is how much? 0. So I will explain. Observe. Employee with a department. This is a employee entity. Which has got some tuples like employee number 1, 2, 3, 4. And I am taking a department instance. This consists of department number 10, 20 and 30 and 40. Now you see how they are participating in the relationship, how they are exchanging their data or how they are sharing their data. So I am denoting as a works this relationship name. So an employee can work only in one department. It may be a 10, it may be a 20, it may be a 30, it may be a 40. For example, a 10 is associated to employee E1. and E1 cannot have references with other departments, and the same department cannot be given to others. For example, you see that, can I give this to E2? No, that's not possible, because only one employee can work in only one department, and only one department can have only one employee. Therefore, the choice got completed in both the sides. So what is the combination you got? E1 is working with 10. So E1 should not come once again, and 10 should not come once again, because you are binding into 1:1. So now the chance has come to E2. So turn has come to E2. So E2 cannot be allocated into 10 because 10 is already busy. Therefore, either it may be given to 20, 30, 40. So if he has given 20, so what is this combination? E2 is given 20. So 20 cannot be given to others and 10 cannot be given to others. Already it is reserved. And E3 comes into the picture. He is going to be given another department. And E4 comes into the picture. He is going to be given another department. For example, if there is a E5 is also there, and you cannot accommodate E5 because almost all the departments are busy. So you have to say that you wait, because you do not have any mapping for E5 because all the departments are busy. If somebody is left from the department, then I can able to allocate that department to this guy. For example, if E1 is not there, then that 10 can be assigned to E5. Therefore, I am representing using a word null. For example, this side also you want to write, some departments are not having employees, then I can say that the employee column is what? Null. So this is how the employee numbers are 1:1 associated with your department numbers. If you observe that, you do not have any kind of redundancy in the relationship. Therefore, 1:1, the redundancy is 0. Clear, friends? Now let us see 1:many mapping. So this is a 1:1 mapping. I already discussed. 1:many mapping. What is this? If I am saying that E1 is associated with a 1 in the relationship and E2 is associated with that side M. So what is the meaning of that? You need to look the cardinality always opposite direction. So E1 maximum cardinality is a M and E2 maximum cardinality is a 1. Please understand carefully. But earlier I have not stressed this point because E1 maximum cardinality opposite direction only 1 and E2 maximum cardinality opposite direction is a 1. That's why I have not stressed. But I am stressing here such that the maximum occurrences of E1 you need to look at opposite side, that is a M. The maximum occurrences of E2 you need to look at the other side, that's nothing but 1. What is the meaning of that? An entity of E1 can be represented many times in the relationship. And what is the meaning of other side? An entity of E2 can be represented only once. So this is how you need to distinguish 1:many relationship. So an entity of E1 can be associated other side many times. An entity of E2 only associated at most one entity with E1. For example, an employee can work on multiple departments or on multiple projects, and a project should have only one employee. Clear? So let me write that important point. An employee can work in multiple departments or projects, but only one project to be given to one employee. A project at most can have only one employee. So let me write employee number and project ID. So as usually 3 employees I am taking. and two projects I am taking. Now they are participating in the relationship. What is the relationship? The maximum cardinality of employee is a M. An employee can work in many projects. What is that? Employee number, project number. So employee 1 can work in a project 10. Employee 1 can work in a project 20. So many projects he can do. An employee 2 can work in project 10. Employee 2 can work in project 20. Employee 3 can work in project 10. But what is reverse? A project can have only one employee. In such case, what is going to happen? This is going to be violated because the project 10 has got how many employees? E1, E2 and E3. So this is violating other side. So this is how you can able to designate how 1:many is going to. So let us write exact point. What is that? An employee can work into employee 10. An employee can work into employee 20. That means employee E1 is working on many projects. So 10 is already given, 20 is already given. Now I am saying that the project 30 has got only one employee. And project 20 already got an employee. Project 10 has already got an employee. Therefore, they have come only once. They have come only once like this. So, an employee can work in many projects. And what is the other sentence, other side? So, other side you tell me. So, project towards to employee. What is that? It is a one cardinality. So, a project can have at most one employee. So this is the perfect example for this, how they are participated in the relationship. So this is how about one-to-many. An employee can work on multiple projects, but a project can be given to only one particular employee. Now what is the next one? Many to one. What is a many to one? E1 side is a many, E2 side is a one. Please understand. Cardinality is mainly talking about maximum occurrences. Therefore, you need to look at always other side. So this side is a M and this side is a 1. What is the meaning of that? An entity of E1 can come only once. An entity of E2 can come many times in the relationship. So that is a statement I have written. So reverse we want to write. What is that? Employee and projects. So project side. So what is the cardinality? M1. So this is a M, this is the 1. What is the meaning of that? An employee maximum cardinality is a 1. A project maximum cardinality is M. Therefore, how they behave? Employee number E1, E2, E3 and project number project 10, project 20 and project 30 and both are participating in the relationship and we are testing the cardinality maximum. So employee number and project number. An employee can work in only one project. So E1 is given to project 10. So he cannot have another project. E2 also can have 10. Please understand. E3 can also have 1. What is the meaning of that? An employee is working only one particular project. E1 is working in 10. Fine. E2 is only working in 10. E3 is only working in 10. So one employee, one project. But reverse, you see, what is that? The same project can have many employees. So 10 has got E1, 10 has got E2, 10 has got E3. This is, you can write many is to 1. Always maximum cardinality, you need to look at the opposite direction. Many to many. So employee E1 entity, employee E2 entity, it's a quite opposite to 1 to 1. So you will have good redundancy in this. Up to M into M redundancy you will find. So the maximum cardinality of M, E1 is a M, and the maximum cardinality of E2 is also M. That means an employee can work in several projects, and each project can be assigned to several employees. So employee and project. Employee number, project number, E1, E2, E3, project 10, project 20, project 30, how they are participated. So the maximum cardinality of employee is M, maximum cardinality of a project is also M. What is the meaning of that? An employee can work in many departments, which means E number, D number. So E1 can work in 10, E1 can work in 20, E1 can work in 30. So fine, an employee can be given many departments. And reverse, a department, same department can have multiple number of employees. This is given to him and this is also given to him. So how much maximum redundancy you can do? So 3 employees are working in 3 different departments. So therefore, your maximum product if you not have a null values, it is M into M. So 3 employees can work in 3 departments. Therefore, you are going to get a 9 mappings, which are nothing but the relationship consists of 9 rows. Okay, friends. So this is about how about maximum cardinality. Now, minimum cardinality we want to discuss. The minimum cardinality is a deciding factor by the participation constraint. One is every student must join for project. Again, every employee must work in department. So when you write compulsion, it is a total participation. An employee may or may not work in department. An employee may or may not have projects. Or a department may or may not have employees. Course may or may not have students. When you go for optionality, then it is a partial participation. First one is a compulsion. An entity should participate in the relationship. So minimum cardinality is a 1. At least one time a tuple should come. And an entity may or may not come. So the minimum cardinality is 0. So partial participation, the minimum occurrence is 0. And total participation, the minimum occurrence is a 1. Because participation constraints mainly talking about minimum cardinality. There are 2 minimum cardinalities. One is 0 partial participation. The other one is a 1 total participation. Okay. Cardinality ratios represent a maximum and participation constraints represent a minimum. So friends, according to this, the participation constraint specifies whether the existence of an entity depends on it's being related to another entity via relationship type. So the constraint specifies minimum number of relationship instances that each entity can participate in the relationship. Sometimes minimum cardinality constraint is called as participation constraints. So I will show you how the TP and PP are going to work. Total participation is a double, partial participation is a single. Total participation value is a 1. A tuple should come at least once. A tuple may or may not come. It's a 0. So let us see total participation. Total participation is nothing but existence dependency. Total participation you can use for strong entity as well as weak entity both. But every weak entity is supposed to be total participation. Last session I discussed. Because weak entity do not have any existency, it has to depends on strong entity. Therefore, dear friends, observe carefully. What is that? Every weak entity must be a total participation, but total participation may or may not be for strong entity. When I say weak entity, it's a compulsion total participation. When I say total participation, it may or may not have two strong entity. It may not have. So that example also I'm going to specify. So what is a total participation? Every entity whichever is there in your table should come at least one association in the relationship. So minimum cardinality of a total participation is a 1, and two other rules are there. What are that? Every weak entity or every weak relationship is a total participation. But total participation can be for strong entity. Now listen. An example is every employee must work in the department. Every employee must work in the department. So employee is a compulsion that whatever employee you are recording, that employee should come at least once in the relationship against with some department number. For example, department number 10, 20, 30, 40. I'm talking towards employee only, as employee is a given total participation because every employee should work in the department. That means whoever the employee is recorded with you, they should come. So E1 coming to the relationship, E2 associating in the relationship, E3 is associating in the relationship. As and when you enter, it's supposed to participate in the relationship, right? So E1 must work in department. E2 must work in department, any department. E3 must work in department. So this is the compulsion. Whoever you record, that must come at least once according to total participation. So the total participation can be represented for double line. Every weak entity is a total participation. See that? Right hand side entity is a weak. This is a weak entity. Therefore, it's supposed to be total participation. So one more example I will write. A student must take course. A student must take course. Compulsion. And one more sentence I will write. Every course must have student. Every course must have student. So how are you going to represent? Both are total participation, compulsion. Whatever data you enter in a student, that should participate in the relationship. Whatever data you enter in course, that's supposed to participate in the relationship. Therefore, let me write a student entity and here course entity. They are participating in the relationship totally. They are participating in the relationship totally. Totally means what? Double line. That's it. So what is the minimum occurrence of a student? I say student 1 and student 2 and course 1, course 2. What is the meaning of that? Every student must take a course. For example, S1 opted course 1 and S2 is opting C2. So whatever data you entered in student, that should participate in the relationship. Whatever data you entered in the course, that should participate in the relationship. For example, there is a C3 which is do not having any mapping. This is against the rules of total participation because it do not have a mapping. Therefore, it's supposed to map. So therefore, better you remove this C3. So what is the meaning of that? Every student must take the course and every course must have students is the concept of both sides total participation I have written. That is the bound constraint that both should come at least once. Every tuple should come at least once in the relationship is a compulsion that an entity should participate in the association is a concept of total participation. Clear? Let us see partial participation. Whenever you talk about the partial participation, so two important points I said according to total participation. Every weak entity is total participation. And another point is that weak relationship must be total participation. But one more point I said, what is that? Total participation may or may not be for strong entities. When it is may, when it is may not, I will show you. Let us talk an example. There is customer bank. So customer has got customer number and the bank has got account number. And I am associating in the relationship. So they are associating like this. You can decide which is a compulsion, which is not a compulsion. According to this example, real-time scenario, when you speak, customer is a strong entity because it has got identified key column. Bank is also strong entity because account number is a what? Key column. But you understand, whenever you are opening an account, that should be associated with a customer or citizen. If there is no citizen, there is no use of maintaining your bank details. That's why, dear friends, what is important point is that, so when you are entering some bank information using a bank account number, So account number 123, it should be participated with your citizen, because every bank account is associated with the word citizen only. Even though it is a strong entity, it's supposed to be a total participation, because the bank database depends on your citizen database. But you observe, a customer may or may not have a bank account, or a citizen may or may not have a bank account. Therefore, it's not compulsion, it is a partial participation. So how are you going to fill the data? For example, there are two account numbers are there with me. Every account number should be associated in the relationship as it is a total participation. Now, once you look at the partial participation such that, so customer C1, C2, C3, C4, C5. C1 has got account with a bank. C2 also has account with a bank. C3 has also account with a bank. But C4 do not have any account with that branch, and C5 do not have any account with that branch. So this data may or may not come in the relationship, but every record whichever you are entering in the bank should be associated with the relationship. Therefore, the minimum cardinality here, a row may or may not come, 0. This is your minimum cardinality. And according to this bank side, the minimum cardinality is what? 1. Compulsion. Like that, many examples are there. Person and driving license. Person and driving license. You know, every person may or may not have a license. But whenever you say that there is a license associated, it is associated with a person only. Therefore, this is going to be a total and this is going to be a partial, how they are being communicated. So, what I want to say, your person entity identified with a what? Social security number or person number. And your driving license is also strong entity. Why? Because it is identified uniquely your license number. In that case, this is a strong entity and this is also strong entity, as they have identified a unique columns. But a strong entity can be a what? Total participation, and a strong entity may not be a total participation. So person may or may not have a driving license, but every license supposed to be associated with a what? Person. That's why it is a compulsion. So what is the minimum cardinality? The minimum cardinality, every row should participate. And what is the minimum cardinality? 0. He may or he may have what? License. So like this, many kind of examples are there in real time. Like citizen with Aadhaar number. Aadhaar database is a total participation. A citizen may or may not have Aadhaar number. Whenever you say that there is Aadhaar number, that's supposed to be associated with the what? Citizen. Now let us focus on to partial participation. An entity of a particular schema may or may not associated in the relationship. It's a optional. A tuple may or may not occur in the relationship. Therefore, the minimum cardinality is how much? 0. So this is an example of partial participation. An employee may or may not work for a department. Therefore, straight line, partial participation. So minimum cardinality, 0. So now let me give an example like this. Every employee must work for a department. Must work for a department. Employee is supposed to be a total. Must work. Every employee must work in a department, though minimum supposed to cardinality is a 1. An entity should come at least once in the relationship. But department may or may not have employees. Therefore, it is a partial. An entity may or may not appear with the relationship. And both are talking about minimum cardinality. This is a minimum. This is the minimum. Comma, maximum. Maximum we will discuss with the help of cardinality ratios, which are already seen. And another example is every employee must work for a department total. Every department must have employees total. So minimum cardinality, this side is also 1, this side is also 1. And next one, dear friends, another example. An employee may or may not work for a department, and a department may or may not have employees. So both are partial, may or may not come. That's why minimum cardinality of employee 0 and minimum cardinality of department is how much? 0. Now, let me show you. So this is how you are differentiating partial participation and total participation. So here, as I already told you, customer and a license. Every license held by customer. A customer may or may not have licenses. Therefore, customer is a partial and a license is a what? Total. But both are strong entities only. Weak entity means I agree that every weak entity is supposed to be a total, every weak relationship is supposed to be a total. But sometimes the total participation also for strong entity. And another example, person with Aadhaar. Both are strong entities as they able to form a key attribute. But you observe carefully, every Aadhaar must belongs to a person may or may not have Aadhaar. If I say every person should have Aadhaar also, then the left hand side is also supposed to be a total. And cardinality constraint. What is a cardinality constraint? A limit I am going to specify. Please listen carefully. Before entering into that, I want to give a solid example so that you will get a clarity how you can differentiate participation constraints with the cardinality ratios. So listen carefully. A student must take at least one course and can take maximum of 20 courses. This is the first point. So according to first point, how will you write it? I can write student, entity and course entity. Every student must take the course. That means student is a total. And how many courses he can take? Maximum 20 courses. Look at opposite direction, maximum cardinality. Minimum course 1, maximum course 20. Second statement, a course may or may not have students. But there is a limit. But a course can have at most 40 students. So you cannot cross this. You can have up to 40 mappings only. So what is the diagram of this? So course may or may not have, therefore it is a partial. And this course can have how many? 40 students. So minimum cardinality according to this is how much? 0. Maximum cardinality is 40. Clear na? One more example. You tell me what is the answer. You guess me and chat me what is the answer. There is a course, there is a student. Between them, there is a relationship. And they are saying that 0 and 10, 1 and 4. So what is the meaning of that? Minimum cardinality is a 0 at course side. Minimum cardinality is a 1 at student side. And student maximum cardinality is a 4. Course maximum cardinality is a 10. Therefore, what is going to happen? You know what to write the sentences. Both are partial participation. And you know the maximum cardinality of them. I can take another example. Student and projects. And I am taking arrow. I am taking straight line. What is the meaning? Please understand. What is the meaning? Arrow indicates a 1, straight line indicates a M. This is maximum. What is a student minimum and maximum cardinality? Minimum how much? Maximum how much? Project. Minimum how much? Maximum how much? Listen carefully. So student minimum, there are no double lines. Answer 0. Project 0. And student maximum, project maximum. So this is how you know how to write in the sentence formats. Okay. If I am taking books and authors, and you see they are participating in the relationship. So he is asking, what is the relationship? What is the minimum and maximum cardinality? Please chat with me. So minimum how much? Minimum means whether it is a partial participation or total participation. Maximum means maximum cardinality. As minimum both are TP. Maximum both are straight lines. Okay friends. So this is how about you can write this situation. A book must have an author. Every book must associated with the author. And a book can have many authors. Like database management system can be written by Korth, can be written by Raghuram Krishnan, can be written by some other person. So a book can have many authors, but a book must have at least one author. Reverse. An author must write at least one book, but an author can have many books. So if I put it in the form of 1M, so books and author. So now I am mixing total partial 1M together. They are participating in the relationship. So what is the meaning of this? The minimum of a book side may or may not come. Author must come. Book maximum cardinality M A book can have many authors, but an author must write only one book. Okay, friends. So this is the different kinds of formations you can write. Sometime I will say employee versus department. So now I am giving a number 2010. So what is the minimum cardinality of employee? Straight line single. Straight line single. Maximum. Maximum. Right? So this is how you can differentiate. This is nothing but indirectly many. This is nothing but indirectly many. Many is nothing but more than one. I can write the same example like this using min-max notation. What is the min-max notation? You need not worry that how to represent minimum and how to represent maximum. The min-max notation will tell you this information. Employee is participating in the relation with the department, and there itself we are going to find every entity beside we are going to specify minimum, maximum, 0, 10 and 0, 20. This is an exact equivalent diagram to this. So every diagram you can able to convert into min-max notation. Minimum is always either 0 or 1. Maximum is always either 1 or m. Okay, friends. So if I am taking last example like this, employee and department. Now I am writing in a min-max notation. 1 and 5, 1 and 2. What kind of participation it is? Is it a total participation or partial participation? This side is a total, this side is also total. What is the minimum cardinality? Minimum cardinality is a 1 and minimum cardinality is a 1. So what is the maximum cardinality? It is a 5. What is the maximum cardinality? It's a 2. So now let us talk about cardinality constraint. How I said it is given like this. It specifies lower and upper bounds on the number of relations each entity can participate. So you see employee versus works versus supervisor, it is a 1n. So this is how you are going to see that what is the meaning of 1n and what is the meaning of 0 comma n. I already shown you min-max notation. This is a 1n. 1 stands for total participation, n stands for maximum limit. And this is a 1-1. What is a 1-1? Compulsion, total participation, only one time only you can able to participate with the others. So what is the meaning of this? So look at course and student. So double arrow, total participation. What is the minimum occurrence? 1. Maximum 20. Student also total participation. Minimum occurrence 1. Maximum occurrence 3. So the same you can able to write with the help of what? Pair of numbers m comma n placed on the line connecting an entity to the relationship. M is a minimum number of times a particular entity should appear and n means a maximum number of times an entity can appear. So 0 indicates a partial participation and 1 greater than 0 indicates a total participation, which is nothing but 1. So if you look at this example, course versus student 1 comma 20. So minimum cardinality 1, maximum cardinality 20. So minimum cardinality is a 1 and maximum cardinality is a 20. An answer to my question. There is an entity E1, there is an entity E2. This is a weak entity. So the participation, every weak entity is supposed to participate in the relation, and that too every weak entity side is supposed to be a total participation. And weak entity is supposed to be associated with a strong entity, and the relationship is named as weak relationship. So what kind of a participation we use at E2? That is a total participation. Every weak entity and every weak relationship supposed to be represented with a total participation. And I already told you another important rule is that E1 is the weak entity and E2 also weak entity. They are trying to form a weak relationship. Is it a valid or invalid? We will say this example is invalid. If I am saying another example, two strong entities E1 and E2, and they are participating in the relationship either 1 to 1 or 1 to m or many to 1 or many to many, totally partially, we don't mind. This is a strong entity, this is a strong entity, you know, because it's a single rectangle, and this is a strong relationship. Is it a valid? Yes, it's a valid. Strong entity can be with a strong entity, but weak entity cannot be with a weak entity, and weak entity is supposed to be with a what? Strong entity. So you can rectify here. E1 is a strong and E2 is a weak. So this weak can be represented with a strong, and this side is supposed to be what? Total. So this is how you can write minimum cardinalities and maximum cardinality. According to this diagram, what is the minimum cardinality? What is the maximum cardinality? According to this example, I am talking, it's a straight line, which means M. This is a straight line, which means M. And a single line, partial, single line, partial. So you know, minimum, maximum, minimum, 0, maximum, M, minimum, 0, maximum, M. And this example, this is given like this. So this side straight line M arrow 1, and is a total participation, and the other one is partial participation. So therefore the minimum is a 0, maximum M, you know why, and this side minimum is a 1 and this side maximum is a 1. Okay friends, so this is how you can identify structural constraints. And in the next session, we are going to see that the mapping routes, how you can able to reduce ER model. Instead of creating several kinds of relationships, you can also able to reduce number of tables. So we are trying to do what? Minimization of ER while you are converting into relational model. That's nothing but mapping of ER model to relational model. So that is actually important for us. After learning that this day and yesterday's session, we got some idea how to represent the things well. Using this, we want to apply the cardinality rules, mapping rules to convert your conceptual design into relational model. Relational model is not going to see that all the conceptual model is going to be created. We are trying to eliminate some of the representations because you can do minimization of ER. That minimization of ER into relational model we will learn in the next session. And dear friends, Let's Crack GATE CSC is our YouTube channel. Please share to everyone about our YouTube channel. Successfully, Unacademy is running a different sessions from different faculty members. Subscribe our channel, hit the bell icon for latest notifications and updates. I use my referral code to get the admission, convert the admission into Unacademy, so that I can able to share all my experiences and materials. So stay tuned to Unacademy and stay tuned to my classes. In the next session, we meet with ER to relational model mapping, which is a compulsion question in the GATE or any kind of examination 1 to 2 marks. Thank you very much.